Chapter 10, Human Alteration of the Atmosphere. Section 10.2, Atmospheric Pollution. So we can define air pollution as a condition in the atmosphere where the concentration of certain substances become high enough to cause toxicity to life, damage to inanimate things, or a change in natural atmospheric processes. Atmospheric pollutants can be gaseous, liquid, or solid in form, and they can be natural. They don't have to be human-made. Air pollution is also not confined just to outdoor environments. Indoor air pollution is a major problem, especially in the developing world. Over 150 different types of indoor air pollutants have been recognized. Some of the more common pollutants include cigarette smoke, smoke from cooking, but other ones that are extremely toxic and can initiate disease are things like asbestos, pesticides, and other types of human-made chemicals. The following graphic shows some of the common indoor pollutants found in various rooms of a home. So here we see bedroom. At first, chemicals, a pretty hard one to pronounce, but essentially it's pesticides that are used in mothballs. Mothballs were quite common when I grew up. Many people had them in their closets to keep moths from eating away their clothes. There was a fear. Dust mites are a common pest and pollutant found in blankets, pillows, mattresses, carpets. Some people have allergic reactions to dust mites, and dust mites can cause asthma attacks. In the kitchen, some of the common indoor pollutants include pesticides, volatile organic compounds, and asbestos. In the living room, styrene can be a problem. It was used to make carpets. It can cause kidney and liver damage. Tobacco smoke is another pollutant, and carbon monoxide. In the bathroom, there's a whole bunch of compounds listed. Air fresheners contain chemical compounds that are not good for human health. Mold is a big problem in bathrooms because of high humidities, and volatile organic compounds are used in many household cleaners that we use to keep our bathrooms clean. In basements, a gas that can seep from bedrock can accumulate in basements, and that's radon 222. So it's a natural compound, and it can lead to lung cancer. Some other pollutants include methyl chloride, carbon monoxide, and once again mold, damp, dungy basements. So we can categorize air pollutants into two different major types, primary pollutants and secondary pollutants. Primary pollutants consist of substances that include dust, gases, liquids, and other solids that enter the atmosphere through natural or human-made events. The main primary pollutants are carbon monoxide, sulfur oxides, nitrogen oxides, volatile organic compounds, and particulate matter. Carbon monoxide is a colorless, odorless gas that is highly toxic. It's primarily produced by the incomplete combustion of fuels containing carbon, also created naturally from sources like decay of organic matter in wet environments. Very serious form of pollution because you don't notice you're being affected by it, and it begins with a headache, and then drowsiness, and then you lose consciousness. Sulfur oxides are another important primary pollutant. They're produced by the burning of sulfur-rich fossil fuels like oil and coal. The most common form of sulfur oxides is sulfur dioxide. Sources for human-generated sulfur dioxide include smelters, petroleum refineries, power plants, and other industrial processes that burn oil or coal. Here's a photograph from inside a smelter where they're producing metals. Nitrous oxides form at high temperatures when nitrogen and oxygen react. The main human sources include burning of fossil fuels for transportation, power generation, and industrial processes. Nitric oxide and nitrogen dioxide are the most common forms of this pollutant. Here we see a photograph from India showing traffic congestion, and the pollution produced from these automobiles would include nitrous oxides. Volatile organic compounds, or VOCs, are organic molecules that are mainly composed of carbon and hydrogen atoms, hydrocarbons. Most VOCs are natural in origin, but they can be released from emissions related to human industrial and transportation processes. Some common VOCs that humans emit include methane, benzene, formaldehyde, and chlorofluorocarbons. Particulate matter is our final type of primary air pollutant that we'll discuss. It can either be liquid or solid particles. And these are particles that are small enough to remain suspended in the atmosphere for long periods of time, so that they're able to, they're so light that they're able to stay lifted in the air due to normal updrafts. Some common types of particulate matter include smoke, pollen, and dust. So these are naturally produced. Now, of course, some of the fires that are occurring on our planet now with vegetation are not actually, we can't really define them as natural. They're being enhanced by things like global warming or just the presence of humans and fire. But forest fires do produce a lot of particulate matter. And of course, forests are being burned in tropical and subtropical areas to clear the land for other uses, including cropping and livestock. Particulate matter is defined by its size. So there are two size ranges that are commonly reported on. The size ranges are less than 2.5 microns or micrometers, sometimes referred to as PM 2.5. And the other larger particles are less than 10 microns or micrometers, PM 10. In here we see the relative size of these particles to a human hair or a piece of fine beach sand. Now, urban areas and industrial activity and transportation are the primary sources of particulate matter air pollution from humans. Urban particulate matter can also include small particles composed of iron, copper, nickel, and lead, which at high concentrations can also be toxic. So table 10.1 shows our typical sources for primary pollutants and the types. So natural, volcanic eruptions, particulate matter, sulfur dioxide, ocean waves, particulate matter, salt, vegetation fires, everything's listed in this table. Take a closer look at it for where different types of primary pollutants come from. So now let's talk about secondary pollutants. Secondary pollutants are made from primary pollutants that have reacted with each other or with some basic component of the atmosphere. And this produces a new toxic substance or substances. And probably the most famous secondary pollutant out there is photochemical smog. And photochemical smog consists of a number of different secondary pollutants that are quite hazardous to human health. Now, certain environmental conditions influence air pollution. Some environmental conditions make pollution worse. Some conditions make it better. And probably the most important environmental condition influencing air pollution is wind, because wind has the ability to diffuse pollution, to mix it with a larger volume of air, making it less toxic. So what we're talking about is a dilution effect, and this dilution effect is directly controlled by wind speed. The faster the wind blows, the more mixing that occurs, the more diffusion that occurs in a larger portion of the atmosphere. The absolute worst condition for air pollution is calm winds. And here in the Okanagan, that's quite common in the summertime, especially considering our valley situation and typical inversions that occur in the summer. Pollution can concentrate in the valleys when wind speed is low. So this diagram illustrates the function of diffusion. So if there's pollution coming out of this smokestack, if the wind is 10 meters per second, we can see the diffusion that would occur with distance. 20 meters per second would create much more diffusion, both away from the plant and vertically in the atmosphere. As I said, still wind, calm conditions enhance pollution. Another thing that enhances pollution is how the nature of the atmosphere. Is it stable or unstable? So stable atmosphere, there's not much mixing occurring in the vertical. An unstable atmosphere, there is a lot of mixing with altitude. And unstable conditions are much better for diffusing pollution than stable conditions. You can, if you look at smoke coming out of a stack, you can determine whether the atmosphere is stable or unstable by looking at the behavior of the pollution cloud coming from the stack. So the top image shows a stable atmosphere, and the pollution just comes out as a wisp, out an elongated wisp outside the stack. Neutral atmosphere, you get a coning plume, and then unstable atmosphere, the plume is loops. It moves up and down with the movement of the air up and down in an unstable environment. I mentioned in Kelowna, in the Okanagan Valley, temperature inversions play an important role in concentrating pollution in the summertime and making pollution a bad problem. So temperature inversion is where you get a layer in the atmosphere that stops the vertical transfer of air and pollutants with higher altitude. Temperature inversions usually involve cooler air sitting on top of warmer air. And as it says, it reduces vertical mixing. And here we see a condition where we don't have an inversion layer, and the cloud is just, the pollution cloud is moving up in altitude, unimpeded. And in the bottom diagram, we have an inversion layer, and it stops the pollution at the altitude that it occurs at, and it concentrates, the pollution concentrates in this lower part of the atmosphere. Topography is an important factor in influencing how severe air pollution can be. An urban area in a valley usually has poor air quality. It's susceptible to pollution becoming more toxic, and valleys tend to have inversions. And those inversions stop the upward movement of pollution. So here we can see a valley condition. If an inversion develops, the pollution stops at that inversion layer and then concentrates in the lower atmosphere. Now you can imagine that valleys also influence winds blowing across. So a city located in the valley is probably got calmer winds than if there was no mountainsides on either side of the city. Winds would more easily blow across and move the pollution away from the urban setting.